Now let's do an example using equations. Now, depending on the equation, will determine what kind of restrictions we have on the domain. So let's look at this first. We have a rational equation, which means it's a fraction. And remember, in fractions, we're fine as long as the denominator is not 0. So we have to determine where does that denominator equal 0. So we need to factor that denominator times an x plus 4. Let's solve for that equal to 0. So either x minus 7 equals 0 or x plus 4 equals 0. So these are the two values that we are not allowed to use in our domain. We cannot have a 7. We cannot have a negative 4. Two ways that we can actually represent this domain. You may see some using what we call set builder notation or just set notation, where it says all x such that, and we can just say x does not equal negative 4 or 7. If we are doing it in interval notation, it may help you to graph it, to visualize all of the intervals. We know that negative 4 is excluded and 7 is excluded, but everybody else is included. So we have 3 intervals. Remember, it goes from negative infinity to infinity. So we can represent our domain with this first interval here, we'll call it A. It goes from negative infinity to negative 4, but parentheses because 4 is not included. Or we can pick up again at negative 4, go all the way out to 7, but 7's not included. The parenthesis just means we go to 6.9999999 forever. And that would be this interval B. Or this last interval C, we could say or 7 to infinity. So that's where the unions can come in handy as well. On B, again, we're looking at a square root. But remember, in the real number system, we cannot take the square root of a negative number. So that means the radicand, the inside of that radical there, has to be larger than or equals to 0. So greater than or equal to 0. 0 is fine. We need the square root of 0. So if we solve this, we say x has to be greater than or equal to negative 6. So for our domain, if we're using interval notation, greater than or equal to negative 6 means negative 6 is the smallest number we can have, and we can go all the way to infinity. But if it helps you to graph it first, to visualize where that interval is, go for it. Last example here is a polynomial. There's no restrictions. I can multiply any number. I can square any number. I can subtract any number. Polynomials will always have a domain from negative infinity to infinity. Coordinate tables, we have x and y. And remember, the domain are all the input values, but these are not intervals. So we can list them by using our braces. And generally, we list them in numerical order. Now, in this table, I kind of mixed up all the numbers. So the smallest is negative 5. Next smallest, negative 1. Then we have 2, 3, 4, and 10. It's always a good habit to put them in numerical order. But notice, I don't know, as far as this table, 2.5's not included. 7's not included in the domain. So we can list them. It's not an interval. For the range, we're going to use the y values and same thing, just list them in numerical order. The smallest is negative 1. No, it's not. There's a negative 6 there. I didn't see it. So we have a negative 6, negative 1, 4, 6, 7, and 12. I think I got them all there. So that is it for function and function modeling. I hope you enjoyed it. See you soon. Bye.